Looks like you've got mail. Meanwhile, back to the real thing. I can see a triangle here. There's no right angle. It looks like a right angle, but it doesn't have it drawn there, so it's not a right angle. We're happy that it's not a right angle. Thinking, do I have three sides operating in this question? Well, it's got three sides, but this is just blank. So looking at that triangle, I can see in operation, I have two sides, something here, something there, and two angles. And I do believe someone in a previous video exclaimed to you and explained, hey, that means I'm going to use the sine rule. I'm going to use A on sin A equals B on sin B. I better label it up to make that happen. Well, 2337x. So let's put big A here, little a there. Big B here, little b there. C is not sort of in operation. So A on sin A equals B on sin B is X on sin 48 equals 23 on sin 37, or X equals this after I multiply. Oh, well, that's pretty easy to get X by itself. I do believe it's going to be in centimetres. Showing a lot of confidence here. Let's reach for the calculator. 23 times. Looking here. Still trying to work out which is the best angle here. So now I'm going to put this part in brackets. So I'm really clear the sin is finished with the 48. And now we'll divide by sin. Okay, we get 28. Have a look at the picture. This one's 37, it's 23, 48's a little bit bigger. So this needs to be a little bit bigger than 23, which it is. 28.4. No particular details about the symbol. Now we just need to wipe the light right out. Next diagram. X 11 115 48. A little a, B little b. A on sin A equals B on sin B. Two sides, two sides, two angles. Everybody is opposite. So X on sin 115 equals 11 on sin 48. I pause to look at this. It's a pretty big number, but I suppose this could go all the way up to 100, like 180 or 179 or something like that, and it should still, the mass should all be still the same. So remove this by multiplying. We're ready for the calculator. Trying again. 11 times sin bracket 115 bracket divided by sin bracket 48. Worthwhile to stop, have a look, check what you've typed in. 13, 11, 13. This looks pretty good. This should be bigger because that's a large angle. 13.4 centimeters. Okay, on with some more. A couple from question 2. So I've got my triangle. I've drawn my triangle in 71. 46 people should always be cool to draw the triangle in. Label up my system. A, little a, B, little b, C, little c. Write my rule. A on sin A. Oh, it equals B. There's nothing for the B. So I guess I'm going to have to use the 5, so it's going to be C. There you go. We get to use the rule properly now. So just looking around the table. Okay, so i.e. I've used this. Cool. There's nothing in C. Well, I hope that everybody can see the angle C is 180, take 71, take 46. It's a little bit of background maths that's in operation all the time. All right. 180, take 71, take 46. Equals 63. So for me to finish this question, I had to do this little extra step. This is, of course, why this is question 2 and how question 2 is different to question 1. Everything else is the same. So the B slot was empty on the side, so I needed to use A and C. Let's finish. X on sin 71 equals 5 for the C on sin 63. It's a simple, we've got x divided by a number, so we multiply by the number. X equals 5 times sin 71, sin 63. Time for Mr. CG. 5 times sin bracket 71 bracket divide by sin bracket 63 bracket 5.3. Okay. This is around about 70. Cool. This one here is around about 63. 5.3. Okay, looks okay. Right, so that's the story with question 2. I think a little bit of sneaking ahead here. I won't do the whole of this one, but I'll just say, hey, that 3 is opposite this angle. And that angle is going to be 100, take 102, take 36. Okay, so it's, well, it's going to be 100. The 100's gone. 80, take like 38 is 42. So in order to do this question, I'd have to find that 42. And now, it doesn't matter if I call this, there's my capital A, little a. I could call this B or C, and there's my little b. And so I'm not actually going to use that 36. I'll just use it to get that number. That's the deal with question 2. All right, I think maybe we'll try and find an angle.